Hi there, welcome to the help video for homework number 5. This is the number sense practice worksheet that you were given in class that is also attached to the Google assignment in Google Classroom. All right, so really quick, I'm just going to explain the directions and then go ahead and get started. So at the top, it says explain why the sum or product of two rational numbers is rational, that the sum of a rational number and an irrational number is irrational, and the product of a rational number, non-zero, and an irrational number is irrational. So we're going to just look at a lot of examples and see what happens when we do those examples. So the first set or group of numbers or sums, the sum of a rational number and a rational number is. We can answer that ahead of time, but let's see what happens. These are all, examples of rational numbers. And if you can't tell by looking at them, when we start to do some of these, you'll see why. So 7 plus 4, that's pretty simple. That's just 11. 1/4 plus 1/2. You can use your calculator to do that. By the way, I do have a calculator I can pull up on my screen. If I wanted to do 1/4 and add to that 1/2. Oops. Let me go backwards here. 1/2. There we go. I get 0.75. Then I can use my calculator and go math, enter, turn it into a fraction, which is 3/4. Or hopefully you could come up with a common denominator. Common denominator would be 4, so I could do 1/4 plus 2/4. That's 1/2 turned into fourths, which is 3/4. Okay. By the way, that's a rational number. 1/6 plus 1/6. I already have a common denominator. That's 2/6, which is also the same as 1/3. If you did your calculator, you'd get 0.3 repeating, and 0.3 repeating is 1/3. Square root of 81 is 9. Square root of 36 is 6, so 3. Square root of 49 is 7, so 0 minus 7 is -7. And then 1/3 plus square root of 9, that's the same as 1/3 plus 3, or 3 and 1/3. All of these are rational numbers. So what happens when you add two rational numbers? You get a sum that is rational. Sum of rational and irrational. All right, I'm going to actually pause the recording, and I'm going to convert all these non-perfect squares. And then when I come back, we'll get the sum and see what happens. All right, so we're back. I rewrote these problems and converted the imperfect or not perfect squares to their equivalent answer. Notice I put ... at the end of them. If you're wondering how I did this, I used my calculator. So I hit second, and then the x squared button. You'll see the little square root symbol above it. That's what we're looking for. And the square root of 7, for example, is this. And instead of writing out all those numbers or rounding, I wrote out, it looks like 4. I went out 4 decimal places and then put ... Okay, now I'm going to add them. And when I add the rational number and the irrational, I get 10.6457. So if you notice, the end of it stays the same. This one, because of the -12, I get -7.8768 ... And then for this one, 12.1622 ... So what's that mean? If I add rational and irrational, I get irrational. Okay, I'm going to pause the video, and I'm going to do the same thing as last time. We already know what these are going to be, but I want to write them out so that you don't have to wait for it. So I'll be back in just a second. Okay, so we're back. This time we're taking the product, so multiplication of a rational and irrational. I wrote out some different ways you can try multiplying these. So this time I used a dot, and we get 21.1660 dot dot dot. So it keeps on going. Here we get negative 49.4772 dot dot dot. Remember, the dot 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 does not mean it repeats. What it means is it continues on forever, and in the way that it is, which is there's no pattern. So it doesn't repeat, and there's no pattern. So again, the product of rational and irrational is irrational. All right, so the last group or last set of numbers, the product of a rational and irrational. If you go through all of these, and I'll try to do so quickly, we get 28. What's nice is when you multiply fractions, you just multiply numerators, multiply denominators, and if you get a fraction or a whole number or an integer, all of those things, or even a decimal that can be written as a fraction, like 1/2, 0.5 can be written as 1/2. All right, all of those are what we call rational numbers. So 9 times 6 is 54. 0 times anything is 0. 1/3 times square root of 9 is 3, which gives me 3/3 or 1. So all of these are rational numbers. Okay, so hopefully that all makes sense. All right, I'm going to pause the recording, flip the paper over, and I'll see you on the other side. Okay, here we are on the other side. I want to go through these statements and make sure you understand what they're saying. This is not a part where you are supposed to do any work. However, I am going to give you a couple of examples that support the statements. So, first one, the sum of two irrational numbers is sometimes irrational. Okay? So, sometimes we can get an irrational number, sometimes we can get a rational number if we add two irrational numbers. The sum of two irrational numbers in some cases will be irrational. However, if the irrational parts of the numbers have a zero sum, in other words, they cancel out, the sum will be rational. Now, let me show you what I'm talking about. So one example is if I took the square root of 2 and I added to it, and then in parentheses I put 1 minus the square root of 2, watch what happens. I'm going to use my calculator for this to demonstrate. So let me clear it out. So I'm going to take square root of 2, and I'm going to add to it, square root of 2. Now I'm going to add to it. I had to stop the radical symbol from continuing there. Now, 1 minus the square root of 2. And then I'll end parentheses. When I hit enter, watch what happens. Dun, dun, dun. Okay, so I'm going to show you another example, and then we'll add these into our document so we can support. So I'm going to take 3 plus square root of 2. Now, keep forgetting to hit that button. If I were to hit enter, notice what I get. That is an irrational number. If I wanted to confirm that, math, enter, enter, and it doesn't convert it to a or a fraction for me. So square root of 2. Okay, now watch what I do. Now this time I'm going to add to it basically something that looks like the inverse. 3 minus square root of 2. And there is a little bit of an inverse here, or canceling out. Enter, 6. 6, so I added two irrational numbers, 3 radical 2 or 3 square root of 2 plus 3 minus the square root of 2. Those are both irrational numbers, but when I add them, the decimal parts of them cancel, and I'm left with a whole number, 6. So that is the other instance or example of a possible situation where irrational plus irrational gives me rational. All right. Same thing with the multiplication or product. If I take 3 plus square root of 2, and you can try this in your calculator, 3 minus square root of 2, and multiply them. I didn't put it in addition, but I put it in multiplication or parentheses. You get 11. So that is what these statements are talking about. All right, I'm going to pause the video and move on to the last thing, and I will see you there. Okay, so I started the next task. It says generate the first 12 perfect squares. So to do that, what you're going to do is you're going to take 1 times 1. And when you do that, you get 1. 2 times 2, you get 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. And I'm going to stop there. I'm actually not going to do the rest of these. The answer key is attached to the homework assignment in Google Classroom, so you should be able to find the key and see what it looks like. I'm going to jump down to this next part here. It says on the number line, label the first 3 perfect squares. So the first 3 perfect squares are 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and 9 comes from 3 squared, 4 comes from 2 squared. Okay, the next task says now write all the irrational numbers in exact form, square root form, where they fit. So, for example, square root of 1 is where this comes from. Square root of 2, if I take that number, second square root 2, and enter, I get 1.41, and it goes on forever. So, but where is 1.41? It's a little bit less than halfway between 1 and 2. So it's like right here. So square root of 2. And then the square root of 3, I think, is a little bit above that. So it's like right here. Square root of 4, that's 2. That's going to be right here. All right. But that's a perfect square. So we wanted the imperfect ones or the irrational ones. All right, I'm going to stop there. Use the key to help you with the rest of this. That's all I have. Good luck. Hopefully, if you've got any more questions, that helps you. But if you've got any more questions, bring them to class, and I'll see you in algebra.